Well, first, thanks everyone for coming out and sacrificing your evening towards the noble cause of getting smarter. I'll try to do you justice here and actually teach you something. Maybe you'll leave learning something you didn't already know. This is a very beginner level, entry level Git, is per the title, Getting Started. I need to click on the presentation. There we go. So I owe you a bio slide because I'm doing a presentation, and that's what you got to do. I work at Microsoft. I'm a senior security service engineer. My team basically provides a highly secure infrastructure as a service to other teams within Microsoft. And so we're traditionally a pretty ops-heavy team, but we're implementing a lot of automation and scripting and PowerShell stuff, and implementing a lot of CI/CD practices that had me teaching my team about Git. And so I've kind of been in that space lately, and so it sort of made sense to take that show on the road, since it's something that not just my team is learning, but lots of people are learning, especially people in the ops space, people who have a PowerShell background and not necessarily a formal development background. So I'm excited to be able to share some of the things that I've learned at work with the people in the community. I used to work at a bunch of other places. I worked in education, I worked in healthcare, I worked at a construction company, and I used to be a Microsoft MVP before I was a Microsoft employee, which means I'm pretty active on social media. You can find me on Twitter. All the links and handles and names and stuff are there. My blog, thomasrayner.ca. My GitHub, which you'll see in a moment. But the one I want to highlight is the PowerShell Discord and Slack. There's links there. Obviously, you can't click them, but you can type them in pretty easy. If you're a cool person, you'll join the Discord. If you're kind of a nerd, you'll join the Slack. Just kidding. They're bridged. They go to the same place. It's a terrific PowerShell community resource. A lot of you guys are probably there already. That's where Mike found me and kind of hooked me up with this speaking opportunity. Highly recommend signing up and joining that community to get some help and meet some like-minded folks if you're not already there. I'm a Pluralsight author. You can see my courses. I've done a couple of them on Azure Automation, so that might be interesting to you if you're kind of getting started automating your ops workloads using Azure. And there's a whole bunch of free ebooks on LeanPub. You may have seen that platform before. The Master PowerShell Tricks books are all on there, and I believe you can get them all for free. So that's me. Moving right along, this one works better if you're in the physical room. But what we're doing here, just kind of doing some level setting so you know what to expect and what not to expect. This is very much a crash course. This is just kind of getting your feet wet and getting in there, and I've got 2 more slides after this before we're going to start actually doing stuff. So not a lot of PowerPoint. We're just going to get our hands dirty and start noodling around in Git. I've got a fun little demo. That's the majority of this presentation, to actually just show you how it's working and kind of explain what's going on as it's going on. I think that's a little bit easier of a way to learn Git than watching a bunch of slides. Simple explanation of what the commands are doing. So I'm just basically talking my way through what I'm doing as I'm doing it. And this is just enough to be dangerous. This isn't going to be, well, what is this not going to be? This isn't going to be best practices or like an end-to-end thing at all. This is not going to be a deep dive or comprehensive. Just enough to be dangerous means we're going to get you up and running. We're going to get you operational. If something goes off the rails, this isn't going to be enough to get you out of trouble. This is going to be enough to kind of get you working when everything kind of goes right, which it always does, so it won't be a problem. And this isn't perfect demos either. These are kind of just contrived examples to showcase the commands more than anything else. So just level setting, very beginner level, very kind of first look at Git for a lot of people. Maybe you've looked and you've tried to follow a guide. It hasn't really gone well for you. This is to kind of defang the whole thing and make it a little more accessible to some folks. Real quick, like before we actually start using Git, we should talk about why you would want to use Git. Like, why wouldn't you just want to save everything in a NTFS share on a server, or why wouldn't you want to just thanks for the kudos on the graphics. Why wouldn't you want to just keep it all in ctemp or something like that, right? The first and foremost, the biggest reason you want to use Git, or really any form of source control, is collaboration. You're great at PowerShell. I know that because you're a member of a PowerShell user group, and you come here and you sacrifice your free time to get better at your craft and to learn related skills to your industry. But you are one person, and so when you're writing code, you have the effort availability of one person. How much faster and better and stronger would your code creation process be if you could work in groups, if you could share your code easily with the community, with people who are geographically far from you? The collaboration opportunities that Git offers are phenomenal, as you'll grow to learn as you start using it. And it's really the next step, like in your PowerShell learning adventure, from when you go from just kind of writing code on your own to writing code as a team, as a department, as a community, or what have you. The collaboration is really the whole point of source control, in addition to things like proper version control. So an example of poor version control is file.ps1, file underscore final.ps1, file underscore final dash copy brackets 1.ps1, et cetera, et cetera, et cetera, right? Like, this is not version control. Using the volume shadow copies in Windows is not version control. Keeping different copies of scripts just in an NTFS share where you have old and new is not proper version control. Proper version control means that you have a way to look at the differences between all of the different versions of the scripts. It means that you can easily roll, or conveniently at least, roll back to an older version of a script. So if you end up the new guy, he deleted everything and he didn't realize that function actually did something when he trimmed it out, and we need to add it back in, but nobody can remember how it works. Well, you can get it in a previous version. Git is wonderful in that it's kind of wonderful and it's not wonderful, in that when you commit something and you overwrite kind of the master version of it, the old versions are all still hiding there somewhere usually, unless you deliberately go and erase them. So you can do things like see people commit accidents where they hard-coded a password and they accidentally stored it in source control. But no problem. I went and I deleted the password, and then I pushed it again into the source control, so the password's gone now. But if someone goes and looks at the older version, password's still there. So you got to be a little bit careful when you start doing this. You have to take care of what you're actually storing, because there is going to be an opportunity to get it back. Can't really hide your secrets as conveniently as you maybe used to be able to. However, that's awesome for when you need to get yourself out of trouble. Speaking of getting yourself out of trouble, it's easier just not to get in trouble in the first place. So change control. This is the idea of having proper checks and balances before you deploy and run code in production. You should not be doing something like remote desktop into a production server, open the PS1 file in the PowerShell ISE, which is so convenient that the ISE is installed already on all your servers. It's just begging to be used everywhere you go. So you open the file in the PowerShell ISE, you change the file, you save the file, and now your production code is all better and working and completely fine, right? Not as much. Not the best choice. A better choice would be allowing people to make their change, and then to propose that change to a group of people who are qualified to review it and approve it, and then for that change to make its way into production, maybe through your testing environments, if you're so lucky to have one. Change control. It's keeping tabs on the changes that are happening in your production environment and measuring their likelihood to succeed rather than to impact you negatively. And then finally, it's the one that maybe a lot of people kind of feel the pressure. You're going to need to learn Git anyway. It seems like. Obviously, you can probably, if you're really determined, I bet you could spend your career avoiding it. But like it or not, the future of ops is going towards automation, going towards being able to write code. You know that. You're in a PowerShell user group. It's not the first time you've had this realization, I'm sure. if you're a developer or something, then you're definitely already familiar with this. If it's not going to be Git, it's going to be some other form of source control, but Git kind of looks like the market leader right now. If you're going to want to have a long, productive career, it seems like you're going to need to learn this type of skill. If you want to participate in the PowerShell community, this is becoming a critical skill. One way or another, Git and just kind of like not mastering it necessarily, but knowing your way around, knowing just enough to be dangerous, is becoming a skill that everybody really needs to have, at least not even in the back pocket, but somewhere within reach. If you think about it like driving a car, well, you got to at least be able to, I don't know, fill gas, change the water, add washer fluid, identify a flat tire, even if you can't change the flat tire on the side of the road. You know, like just very basic fundamental working knowledge is going to pay dividends and be something that can put you ahead of the people competing for promotions and attention from your managers. So that being the case, let's keep moving along and talk about the situation. The situation is our demo. It's what we're going to be doing right now and for the rest of this session to kind of get ourselves familiarized with Git. This is just kind of laying the land. So let's say there is a cool PowerShell module. Wow, that's awesome, right? So far, so good. We love cool PowerShell modules. Cool PowerShell modules are the best. And I found one, and I love it, and I'm going to share it with you. But it's got some problems. It's a cool PowerShell module. It's got problems. I know, but I know how to fix them. So I want to make it better. I want to contribute to this project. There's this PowerShell module. It's pretty good. Does some neat stuff. I want to fix it. I want to make it better. But it's on GitHub. Oh, no. I could probably fumble my way through it and download it and make the changes, and that's cool. But how do I give those changes back to the author? Do I just try to find their contact information and send them an email with their revised code and say, hey, upload this to GitHub. This is all better. No, there's a better way. And so I'm going to show you. This, actually, real quick, just kind of before we do the demo, I'm going to turn off my, there we go. I have an add-on in Firefox that makes everything dark theme, or at least it takes a crack at it. This presentation is based off of a blog post I made a few months ago, and it's just called The 6 Commands You Need to Know to Work with Git. You can find it on my blog, thomasrayner.ca, first Git commands. And up font size, yeah, I can do that. Is that better? How about that? 150%, nice round number. The 6 Git commands you need to know to work with Git. It's not going to be something that we're going to talk about in detail. Just know that it's out there. I recommend checking it out. And I'm basically running through this in terms of a demo because this is all you need to know to be dangerous kind of thing. So you can find that on my blog, thomasrayner.ca /first-git-commands. If you're just on the homepage, it's like the third one down, so it's not very hard to find. I haven't been very prolific on my blog lately. But it's got, like if this presentation goes by quickly, if I talk too fast, or if it's awesome, but you've been playing a drinking game every time I say the word or something, or make a typo. By the way, I'm going to make typos like it's my job. Then you can just find my blog and find this, and you kind of have the reference and the cheat sheet, and you can read it over at your convenience. So there's that. What else do I want to go through? Oh yeah, this is the GitHub desktop application. It's just desktop.github.com. You can see it a little better maybe if I highlight it, kind of not really. The font in the size magnification doesn't change the URL, but it's a desktop client for working with GitHub. So this won't help you if your Git repositories are in Azure Devops or GitLab or something like that. But if you're working with items that are in GitHub, then this may be of interest to you. It adds a visual representation to all of the Git stuff that you're doing. You can kind of see some screenshots here of people using it in action, and GitHub supports it, so it's a pretty decent application. Additionally, there is version control and Git connectivity and tools built into Visual Studio Code. So this comes with it. It can connect to Azure repos. It can connect to GitHub. Again, I'm not reading through all of this, but it adds a bit of a visual representation as well for anybody looking to avoid the command line with this a little bit. The Git command line can be a little bit esoteric. If you like Linux, you'll love Git, because Git was invented by Linus Torvalds. If you don't like Linux and you don't like the command line interface for a lot of stuff, then you might like something like the tools built into Visual Studio Code. It's got Git support, and it does a whole bunch of other things. Like when it detects that you're in a Git repo, it can show you who edited a line of your code last and stuff like that. So it's worth checking out. I just wanted to touch on that. Additionally, if you're looking for more than just enough to be dangerous, there's this Pluralsight course, Getting Started with Git, that I highly recommend. It's one that I've recommended to my teammates before and they've found success with. There's also another one that you can watch after this. It'll be really easy to find, called Mastering Git, which will kind of show you the next level there. But go through this first. This one's a pretty good one. And then the Git documentation. Git is shockingly well documented, given how unuser-friendly people can sometimes feel it is. It's at git-scm.com/doc, or you can just search for Git docs, and guess what the first result is? Oh, weird. My dark reader thing is still on. Off. There we go. This is what it looks like when you don't have extensions screwing with your view. And so you can go and look at things like reference. And here's a list of all the different Git commands. If you're like, oh, what does Git log do? Oh, it does this. And here's all the parameters that it takes. And here's how it all works. It's actually pretty good. And you should definitely check it out. Anytime you get stuck or a Git command is not working like you think it works or think it should work, then check out the docs. Maybe it's case sensitive. Maybe you're doing dash lowercase a instead of dash uppercase a. Right? In Windows, we're not generally used to case sensitivity, but in the Linux/Git world, we kind of are. Question, what if I want to have source control within my org only? Then you'll be looking at something like GitLab or Azure Devops repos. GitHub offers private repositories that you can invite just the people in your organization to. There's a lot of different options. GitHub is just kind of an accessible one that everybody kind of bumps into at one point or another, that we're just using as a free and accessible example. Plus, Microsoft bought it, and I work for Microsoft, so it should be no surprise you're going to see some of that stuff. Just tracking the chat. Yeah, Bitbucket. Yeah, there's lots of options, and I encourage you to go and try a whole bunch of them and see which ones work best for you. At work, my team doesn't use GitHub. We use Azure DevOps repos because our work management is in Azure DevOps boards. And we use the build and release pipelines as well. So we can kind of marry those into GitHub, but all of our code isn't for public consumption. So we use Azure DevOps repos. On to the demo. This is, oh, get out of here. This extension, Dark Reader, makes it so GitHub has a really nice dark theme, but it's not what it genuinely looks like when you're just looking at it without that. So I'll turn that off and blind all of you. This is a cool script. You know it's a cool script because it's written by the user WriteCodePetCats, who is not Thomas Rayner, but I'm sure he's a handsome fellow. And it's called CatFacts. If you're not familiar with GitHub, this is the person's username or their organization name, and then this is the name of the repository you're on. How I got here doesn't really matter because you just found this code. Maybe you found it using your favorite search engine, or maybe it was linked to you, or maybe it showed up in a comment in someone's code or a Stack Overflow thing. But you can see my URL here, github.com/WriteCodePetCats, because that's the username, and then /catfacts, because that's the name of the repository that we're on. and just kind of poking around, familiarizing ourselves with GitHub. This isn't necessarily part of working with Git. This is more just working with GitHub. I've got 2 files. I've got license. I've got get-catfact.ps1. License, pretty boring. It's the MIT license, and it's not really anything worth talking about more than we already have. The meat and potatoes, the most wonderful thing in the whole world, the best script I've ever seen, get-catfact. It's very complicated. It's very sophisticated. It has 3 lines where it has a URL, and then it does an invoke REST method, and then it writes out the fact. So far, so good. So what we can do, and I've clicked on that file, so I'm going to click on catfacts to get back here, is we're going to do kind of our first Git commands. One of the things we got to do, because we're on GitHub, this is not my repository. This is WriteCode PetCats repository. And if you remember from the obligatory bio slide, my GitHub username is just Thomas Rayner. And so I don't have a relationship with this person, despite what you might think from the name and the description of this account. So I don't have permission to edit this code directly. This is somebody else's. So the first thing I want to do is get my own copy of this repository. I want to make my own copy of all of this so that I can edit it and I can improve it, and then the end goal, share it back with the original author and see if they'll implement my changes. And the way I do that, the way that I take this catfacts repository and make my own copy of it in GitHub, is I fork it. F-O-R-K, I fork it. So I'm going to click fork. And I've got a couple of places that I could fork it to, because I've been on GitHub a little bit. And I want to fork it just to my Thomas Rayner account. So I click that. And it takes a few seconds, and it always takes longer when you're standing here waiting for it. There we go. And so this looks really similar to what we saw before, right? I see my license, I see my get-catfact.ps1, and other than it's still GitHub, like nothing much really changed. But if I look kind of at the top here, I see I'm in Thomas Rayner /catfacts, and it's different. And I can see down here, forked from WriteCode PetCats /catfacts. And that is kind of evidence to me that I'm not the original creator of this catfacts repository. I forked it from this original. I can go back and click that link and go to the original place that I forked it from. But this is mine. And I can see github.com/Thomas Rayner /catfacts. This is in my fork. Okay, so a fork is just basically a copy of somebody else's repository that that you want to be able to edit and have control over. So far, so good, I'm going to assume. The next step is, this is great. This is on GitHub. I've got my own copy of this code on GitHub, but I don't edit code on GitHub, do I? Where do I edit code? On my computer. So I need to get this on my computer somehow. I need to get it onto my computer. And the way that I do that is by cloning the repository. So I can come find this green button that says clone or download on GitHub. And this offers me the opportunity to download a zip file of all of the different artifacts inside the repository, or I can click on open in desktop. So if you have that GitHub desktop application, you can do that. Or I'm just going to click the copy button here to copy the repository URL to my clipboard. Excuse me. So I've got that on my clipboard. Click it a whole bunch of times to make extra sure. If you wanted to use SSH instead of HTTPS, you could do that, but that's not standard. And now, for a little while, I'm done with the browser. I can go into somewhere where we're all super comfortable, the command line. This is PowerShell. I have a bit of a unique prompt set up that you'll see some new features of once we get into a Git repo. But I'm just in my ctemp directory. It is empty. And the first Git command I'm going to run is git clone. And then I'm going to paste in the URL there. That's really tiny. Maybe I can make that. Whoa. everything getting jumbled around the side. Is that a better size?
Better.
Better. Let's clear the screen. And so I'm in my temp folder. It is empty. And I'm going to git clone the URL that I copied from GitHub. Okay? Cloning is saying, here's a URL from a spot online, somewhere either in Azure Devops repos or GitHub or GitLab or wherever else your code is stored, and I would like to clone that onto my local repository. This terminal is conemu emulator, console emulator, and I've just got a custom prompt set up. I can show you guys that at the end if you want. So I'm going to clone that. It's going to give me a little bit of information. You can kind of read through that if you're masochistic, but what you really need to know is if I do a directory listing again, no longer is my ctemp directory empty. Now I have another directory named catfax that lives within that. And so I'm still not in the Git repo, but I did clone it. I made a copy of it, and it got stuck inside my present working directory. It's just right where I am right now, and into a subfolder with the name of the repository that I cloned. And so it doesn't matter if I cloned Thomas Rayner /catfax or writecodepetcats/catfax or whatever. It's just the name of the repository. So it can get a little squirrely if you start trying to clone multiple forks of the same repository, and you shouldn't do that. There's other ways of solving that problem without just cloning a bunch of stuff. That is not one of the 6 commands you need to know to get started with Git. But I'm gonna go into my catfax repository, and so my prompt is going to change, and you'll see I've just got this purple and it says master. This is just all custom crap that I added in, but it's going to give us some visual indicators of some things that are going on when we are working with this repository. And so I'm inside of the catfax repository, and I can see ctemp catfax. I got this file, get-catfax.ps1, and I've got the license there that I should totally not do anything to. So I'm good. I got it. It's on my system. That's awesome, isn't it? So far, so good, right? Yes. Awesome. The next thing I want to do is I'm going to create a new branch. What is a branch? That's a new word. A branch is similar to a fork in that you're creating a new copy of data. You're creating a new area where work on the code can be performed without impacting the original source of that code. So you can think of a branch as, say you had this ctemp catfax folder, and you're like, I want to make a bunch of changes to it, but I don't necessarily want to impact the master version, the gold version. So I'm going to copy my catfax folder and paste my catfax folder, and then I'm going to do all my work in the other folder that I made a copy of, and then I'm going to put all those changes back into the original one. That's sort of what we're doing when we say we're creating a branch. We're diverging from the code so we can make our changes in a safe place and isolate them from the known good working code, and we're going to then kind of enjoy that freedom to do whatever we want with it. We can leave it in a broken state without impacting the code that is in production or something like that, or being actively downloaded by millions of people. So the next Git command we need to look at is checkout. Git checkout-b, and then I'm going to name this. Actually, yeah, let's just do this. Fix it. Switch to branch fix it. So there's a couple things going on here. Git, you just have to type that before anything you do. It's an executable, so it's taking arguments after that. If you want to run a Git command, you have to type Git, right? And so the Git command that we're running is checkout. And checkout is the command that you use to switch between branches. So, and you'll notice here my little purple thing changed to fix it. So we already had a master branch by default, and -b and then fix it is creating me a new branch with the name fix-it. So now if I do an ls here, everything looks the same. The last write time is the same. The length is the same. You can see all that. Everything's the same. But I'm in a different branch. You have to just trust me. And before we go too far, let's actually run get catfact.ps1. That was fast. Fact. The Maine Coon cat, blah, 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 is the only natural breed of domestic feline. And then length. And so this is great. But what I want to do, I just want the text of the fact. I don't want the whole thing. So really what I want is that. I just want the fact object out of this thing that gets returned. So that's what I'm fixing. Stevie says, could you show us how to do that in 2 steps instead of combining into one command? What you mean, the git checkout part, Stevie? Like creating the branch and moving to it? You know, I forget. I think it's capital B creates the branch. Is that right? I just always do it this way, and it's muscle memory to me. So yeah, you can create the branch. Oh yeah, sorry. Right, yeah. You can see how often I diverge from my own habits, if you guys can see the chat there. So you could go git branch, and then name of your branch, and that will create the branch. And then you can go git checkout name, and that'll switch to it. I like doing the git checkout -b because it just does that all in one step. It creates the branch, and then it changes your active branch to be that branch. Thank you, Ryan, for reminding me there. Of course, you always forget stuff when you're presenting and talking about it. But this is the change we want to make. Instead of returning the fact property and the length property, we want to just return the text of the cat fact. Sound good? So what I'm going to do is I'm going to go code-r dot, and that's going to open, that's going to open VS Code in the current directory that I've got. If you guys didn't know that you can do that, code-r will reuse the same window that you've got open, and then dot is just for the current working directory. And I can click that, and it opens my file. And I can come in here and go .fact. Bigger. Oh, sorry. It's not the same. Nope. Oh yeah, it's plus, right? Yeah, there we go. Better? Sorry about that. So the change I made was I added .fact, and then I saved it. And one of the nice things about VS Code that you can kind of see, you can see this little, it might be really faint on the recording. I can't highlight it or anything because it's just part of it. Maybe if I hover my mouse there, I can see who changed it. What's going on here? You, a few seconds ago, uncommitted changes. This is all unfamiliar because we haven't really talked about what to do with our changes yet. But this is all information from Git, because the folder that we opened, this catfacts folder, is a Git repository. And so you can kind of see some of that information. And if I go up to this line, I can see write code pet cats set this line up a day ago, and I can see some more information there. We're not going to talk too much about that now because that's not super just getting started stuff. So I fixed the script. It's all better. It's all better and everything's happy. Where did all my stuff go? That was cool. Let's just make that bigger. Did I go to a different? Yeah, I did. Let's try that. There we go. Let's clear our screen. Sorry about that. So you might notice in my prompt, I've got this little changing color on this arrow. We're going to get to that in a second and why that's happening. But if I go get catfact, now I just get the string. Cats are extremely sensitive to vibrations. They can detect earthquake tremors 10 or 15 minutes before humans can. Cool. Get an earthquake warning cat and never be caught off guard again. So I've got that change made. But predictably, if I go back into GitHub and I refresh the page diligently, and I go and I check out the contents of this file, my change is not represented in this file, right? Kind of predictably, like you didn't think we were done, did you? We can't just be done that easily. But I know the change on my local system has been performed. So let's talk about comparing what's on your local system to what exists in other parts of Git. And what you have to know about Git is it's effectively all about moving data between 3 different places. One is your local computer, kind of makes sense. That's where you do all your work. The other is online, so like GitHub or Azure Devops repos or GitLab or Bitbucket or any of the other places where it all lives centrally. But the third place that you have to move data around in Git is called the stage. And so it's sort of an abstract concept because it exists on your local system, but it represents kind of a staging and on-deck area. The theory is you can be making tons and tons of weird-ass changes to your code locally, but you don't necessarily want to keep all those changes. They're not all necessarily ready for prime time, so to speak. So when you're ready to start preserving some of these changes and adding them to your source control, the first thing you have to do is add them to your staging area, and then you can push them from your staging area into your remote repository, so GitHub or somewhere else. So if I want to see the state of my code and kind of with the perspective of my local copy, I can go git status. And this can kind of look weird, but if you read it closely, it's going to tell you everything you really need to know. What branch I'm on. I'm on the fixit branch. I'm not on the master branch. I'm not on any other branch. I'm on my fixit branch. Change is not staged for commit. So what's that? We'll see that in a second. And then it even tells me, use git add file to update what will be committed to GitHub. Use git checkout -- file to discard changes in the working directory. So if I've made changes to this catfact file and I don't like those changes, I can discard them with this command. That's actually surprisingly intuitive. Thank you, Git, for telling me exactly what I need to do. And then it's telling me this file is modified. And no changes added to commit, use git add, blah, blah, blah. It tells you what you need to do to actually commit these changes upstream. So what this is telling me, these changes, this modification of this file, is not staged. So it's not in the staging area. It is not ready to go to GitHub. It is just on my local computer. So of the 3 places it could be, it's only on one of them. The change only exists for me locally. It's not staged. It's not in the remote repository. Okay? But it tells me the command that I need to use in order to stage it. And that's git add. You can go git add. And you can either just type in get, oh, I thought I would tab complete. There it is. I can go git add / get - catfact. Or I can go git add -A, and capital A is just not a shortcut. It's a switch that will add all of the different changes that you've made that are not staged into the staging area. And so I tend to be a little lazy, and I just kind of go -A. If you wanted, you could, if you made changes to multiple files, but you only wanted to stage the changes that you'd made to one, then yeah, use the name of the file. But I only made one change, and I only changed one file. So I can go git add -A. And so in my prompt, just for you keeping score at home, this little arrow changing colors is telling me that my local copy is different than what I have staged. So I'll do git add -A, and wow, now it's green. Isn't that special? And if I go git status again tells me I'm on branch fixit, changes to be committed, and then we'll come back to that, modified get catfact.ps1. So this looks a lot like this, but the text around it and the color, helpfully, is different. What we're hearing now is that the change I made that was just on my local computer has been moved into the staging area as well. And if I screwed that up, if all of a sudden I'm going, oh, I better not have done that, I can use this git reset head and then the file, the name of the file, to unstage that, to get it back out of the staging area. We're not talking about that because everything's going perfectly. This is just enough to be dangerous. So I made my change and I staged it with git add. And then I can see here, this green is kind of an indicator. This green in my prompt is a bit of an indicator that something's different. This is staged and ready to go to GitHub. Okay. So I just want to make sure I'm not skipping anything I wanted to tell you guys. The next thing I need to do is actually create the commit that I'm going to send back to GitHub. And so you can think of a commit as like a package, kind of like a collection or a zip or a summary of the changes. So I've got all of this stuff staged. I've got this file and this change to this file staged. And now I want to bundle it all up and send it to GitHub. And so I do that by creating a new commit. It's ready to be committed. I need to create a commit. That is what we send to GitHub. We send commits to GitHub. So go git commit to create a new commit and -m for a message. All the commits you make and should have a message inside of them that describes briefly the change that you made. So maybe you added a file, or maybe you deleted a file, or maybe you refactored something, or maybe you fixed a bug and that bug has a number. You should reference it here. But for me, I just unwrapped the fact property from the fact returned. That's basically what I did. And when I hit enter, get a little bit of information here. And it's telling me, sorry, I hear. Okay. I'm getting a little bit of information because this is the first time that I've actually done anything through this Git repository. And so it's telling me, you didn't set up your username. You didn't set up your email address. And so I can do that now with git config. Because you can see right now, the committer, Thomas Rayner, and then it's got my Microsoft email address because I'm logged into a Microsoft computer. But this GitHub is my personal GitHub tied to my personal email address. You might bump into this at work where you're logged into your work computer and you've got Git repositories that are for work, and you've got Git repositories that are tied to your personal account, and you'd like to keep them separate. So it tells me exactly what to do to properly accredit this stuff. You go git config global user.name Thomas Rayner. What does that sound? And then I need to get my email address figured out too. So I'll go git config local, and I'll tell you why I did that in a second. Email. Sorry, that's so distracting. This is terrific. So I've done two things here. I've set up my username, like my user.name, just my actual name as being my name. And then I've set up my email address to be my personal email. But I did it differently. Here I did global, and here I did local. And you might go, what's the difference? A global config is going to apply everywhere that you run Git. It's going to apply to whatever repository you're in, whether it's for school or work or home or fun or whatever. It's going to apply. Local config is just going to apply in the repository that you're currently in. So I'm currently in my catfax repository, and I don't want to apply this change to all my work repositories. I just want to apply it to this one. So global, local, and I kind of did that. And now, reading this again, email and address were configured automatically based on blah, 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 blah. After you do this, you can fix the identity used for this commit. And it tells me exactly what to do. Copy, paste. Did I put someone to sleep? That's terrible. And when I do that, this can be a little bit different depending on how you installed Git. This might open VS Code. This might open Vim, like it did for me. This might open Nano or something else. But this is your chance to go change some of the items about the commit that you've made. And so in this one, I did the amend, and it will go and change my username and email address for that one. But I could also change the message. I could change some of the different things that I was doing in here, although I really shouldn't. I don't want to change anything else. I just want to go quit this, save and quit. And now I get the unwrapped effect has been returned. It changed all that. It made an insertion and a deletion. We'll look at that for a second. And so the author information got reset. So now I'm going to get credit for this, which is kind of important, right? And if I go git status again, something deceiving has happened. So as I'm on the fixit branch, nothing to commit. The working tree is clean. So what would you assume? You would assume that the changes I made on my local machine that I then staged in the staging area. I added it to the staging area. And then I wanted to take them from the staging area and put them into GitHub. So I created a commit, and I even went and edited my author information. So they must be in GitHub, right? Let's go look at the catfax repository. First things first, I know I'm on the master branch, and I can switch branches in GitHub. I don't even see my fixit branch. Let's look at the file. My change isn't in the file either. Well, damn. What do I do? We got one more command we need to run, and that is a git push. And that's going to push the commit that I just made, or all of the outstanding commits that I've made, up into the place where I originally cloned this from, if I have permission. So I can hit enter. And if this is your first time pushing from the branch that you're on, like you guys remember, you saw me create the branch. You saw me create this fixit branch. You're going to get this error. You're going to go, Thomas, you don't know what the hell you're doing. You're getting errors all over the place. What are you doing? This is saying the current branch, fixit, has no upstream branch to push the current branch. Like, what the hell does that mean? I'm brand new to this. This is completely useless. But luckily, it tells me to push the current branch and set it, use this command. I don't even have to type. I can be mouse man and copy, paste, enter. And then I get something that looks a little bit more encouraging, right? And this is just doing some of the behind the scenes action to make sure that the branch that I created to isolate my work is now going to end up back on GitHub. So now, if I go back to GitHub, I can refresh my page, and I'm getting a little bit more information here about the fixit branch. I can go into this full file and see, damn, my change isn't there. But anywhere that you see this little drop-down menu that starts with branch, and then it tells you the name of the branch that you're looking at, you can go, hey, fixit, my fixit branch right there. Click fixit, and now my change is in GitHub. Isn't that wonderful? Right? I'm assuming it's just applause and everything, but you've all got your mics muted so you can't hear it. I'm very modest about it. It's okay. So cool. I got my change uploaded to GitHub. I did it in only like 6 commands. But if you remember, that wasn't really the point, was it? The point wasn't to get it into my fork that I created. The point was to get it into the original person's code. And so this can take a little bit of a different shape depending on what the Git system that you're using is, if it's GitHub versus Azure Devops versus GitLab versus something else. But in most scenarios, what you're going to be creating is a pull request. A pull request. And so as the name sounds, you're creating a request for someone to pull something into their repository. So that is easier shown. I'm going to click on the pull request tab. It's going to tell me my recently pushed branches. Here's what I just pushed. 2 minutes ago, I pushed the fixit branch up here. And I could click compare and pull request, or I can just press the new pull request button. So I'll do that. Because if you wait too long, just going back, if you wait too long, this might not show up. Because maybe it wasn't recent anymore. Maybe you made that change, you pushed it up, you said, screw it, I'll make the pull request tomorrow. Because it's 2 a.m. Man, figuring out how to add those 5 characters to that script, that wiped me out. I don't have the energy for this. Do it tomorrow. Oh no, my button wasn't there anymore. So come to your fork or go to the original one. It doesn't matter. You can go do a new pull request. And then GitHub is helping me out a lot here, but not as much as it could. There's lots of documentation on what exactly this menu is telling you, but I'll step through it kind of as just through this line here. On the left side of this arrow, we have the destination. We have where we want the code to go. And we want it to go not to any of these forks, not to my fork. I want it to go to write_code petcat/catfax. And I can pick which branch on that repository that I want it to go to. So if they had a dev branch, maybe I want to push it there. If they had a feature branch or a bug fixes branch or something like that, I could ask them to put these changes there so that it goes into the next release. Write_code petcats, though, only has a master branch. So I'm going to stick it there. On the right side of the arrow, the head repository, this is where I want it to pull from. And do I want it to take this person's catfax or that person's catfax? Do I want it to pull from its own version of catfax? Nope, I want it to pull from my version of catfax. And then the last thing I need to pick is which branch on my fork do I want it to pull from. My master branch, I can see right here. There isn't anything to compare. Write_code petcats master and Thomas Rayner master are identical. So that's not where my change is. Remember where my change is? My change is in the fixit branch. If I go here, GitHub will refresh and whoa, that's all different. I get a little note at the beginning here, able to merge. These branches can be automatically merged. That's awesome. Merge conflicts are not something that we're going to talk about today. But I can scroll down and we'll come back to that button. How many commits did I make? Just the one. I only created that one commit. How many files did I change? Well, I only changed that one file. I don't have any comments. It was just me, the one contributor. When did I make it? Here's the commit that I made. I can click on this and see more information about it, but I won't do that here. And then it shows me real clearly, showing one changed file with one addition and one deletion. And I can split that view and get it on one side or the other, or I can go to the unified view and it'll show me I deleted that line and I added this line. And in this file, that's what that means. I added a line and I deleted one line. So you might go, well, you just edited one line. You modified the line. You didn't add or delete it. That's not really how Git works. Sort of on a line-by-line basis, I had to get rid of that line and replace it with this line. They're both line 3. You can kind of see the numbers there. And I didn't touch lines 1 and 2. They just show in a white background. So this is the change that I want to go from my repository into their repository. Sound good? And so if I'm satisfied with this, if I'm like, okay, yeah, I got the right file here, I didn't modify the license or do anything stupid like that, this is indeed the thing that I wanted to do. I tested this on my side first. You may recall that I ran that afterwards and it worked just fine. And now I can go and actually create my pull request. This is all just me reviewing. I haven't done anything to anybody yet. So create pull request. And now I get to make a title for my pull request. And I get to put in a description or some comments. Sometimes the maintainers of the repository that you're trying to pull into will have this pre-populated with some information or kind of like a form that you want to fill out. But all I'm going to do is go to Google Images, and where's it go? Here we go. Let's take this one. Can I copy that image and paste? And that's all I'm putting in. If you paste an image into a GitHub thing, it'll just stick it in there. I don't think it's animating it, but that's okay. Because you know what? This is a lot of work. And I know how grateful they're going to be that I took an interest in their project. So I just want to say, hey, you're welcome. Not a big deal. I do this all the time. And so realistically, this is the time to make sure that your title is appropriate. You've mentioned any bug fixes that, any bugs that you've fixed by doing this. Provide any additional information that they might need in order to make an educated choice about whether or not they should merge your request or wait or reject it, or if they need some changes. This is just cheekiness because it's fun. So I can choose whether or not to allow edits from maintainers. And I can either save this as a draft, or I can just create it. Stevie with a good point. Inside the comments, you can use some keywords. So if I go back to the right thing, this is all in Markdown. I can go and tag, here's a change I made. I can @mention people. If I had an issue, a GitHub issue, I could tag it by number or by other artifact. I can tag Stevie, what's your username? Stevie Coaster. Something like that. It's not showing up because he's not a contributor on this. But it should show up and tag him anyway. See that? I can tag Stevie. And I can make sure that is appropriate there. And like I said, you can either save this as a draft because this is a lot of work and you want to make sure that it is addressing you've got everything in here that you need it to do. And then when I'm ready, I can click Create Pull Request. And this is going to send the email, so to speak. This is going to say, okay, go and do it. And if I do that, you can tell by my URL, and you can tell by GitHub up here, I've been transported. I've been moved back to the original repo that I'm trying to get my changes put into. And there's an open pull request, and it's pull request number 2. You can see unwrap the fact property from the fact returned. And you can see it's right here. I did this. You can see this is the commit that I added. You can see this branch has no conflicts. What are the files that are changed? We've seen this all before. What are the commits? It's the conversation. And then you'll see I can comment. And I can close my pull request. Closing it cancels it. It abandons it. I can come over here and add a reviewer. This is really all just GitHub specific at this point. But what I'd like to do is show you quickly the other side here. Sign in. Sign in as write code pet cats. So now, yeah, that should be big enough. I'm signed in as the maintainer. I'm signed in as write code pet cats. You can tell signed in as write code pet cats. And so I have just got a pull request. I've got a couple. I've got one from somebody following along, and I've got one from me. And if I click it, I see pretty much everything like we were seeing before. However, I've got a new button that says merge pull request. And I can squash and merge, rebase and merge. Don't worry about that stuff right now. But if you're a first-time maintainer and you're sitting here going, hey, somebody contributed to my project, I don't know what to do. Well, I can come and review it and see what files were changed. I can come in here and have a conversation with them about it. I can add a little happy to it. And I can add a heart to it. And I can add a thumbs up to it. And rocket ship because it's ready to ship. I can do all types of awesome stuff. It's such a great social network. Oh, there's a Loch Ness Monster. And it does tend to automatically update as you're doing your thing. So what I'll say is thank you so much for your contribution. I'm going to add that comment because I'm very polite. And then I'm going to merge the pull request. Hypothetically, I've downloaded this, I've reviewed it locally, I've run all my unit tests, I've done all that good stuff and made sure that it's not going to bork everything up. It's going to merge. And then I can have this opportunity to edit the title and change some of that stuff and then confirm merge. And you'll see this went, I missed it, it went from active to merged. I have this activity that says merged commit. And if I go back into code, on the master branch of the write code petcats thing, and I go back in here, and there's the change. My change is there. It went from here to my fork. I can't fork it because it's my own repo. Let's go back to mine. It went from here, where we found it, into my fork. I've already forked it. Go here. Went into my fork. It went, can I scroll up and still find it? I cloned it. I think I lost that type of messaging. I cloned it, and then I edited it to make this change. I used the status command to figure out where I was in the process. Hey, I had changes that weren't staged. I need to stage those changes before I'm ready to send them back to GitHub. So I use the git add command to add those changes to the staging area. I use git status again to see here are the changes that are ready to be committed. This is everything that's staged. If I wanted to unstage it, I could get some hints here on what to do. But I'm ready to stage it. Sorry, it's been staged. I'm ready to send it back to GitHub. So I have to create a commit. Git commit -m, and then the message. This is a short description of the changes that this commit represents. And then I did a little bit of housekeeping to change my username and my user email. I amended the commit using this --amend --reset -author to make sure that the author information was correct in that commit that I had created. And then on the git status, I saw, okay, good. All my commits are, I don't have anything different between what I've committed and what I've got locally. I tried pushing, but it told me, hey, you just created that branch. You're not ready to push yet. You have to do this set upstream mumbo jumbo to make sure that it makes it back up to GitHub. So I did that. All my changes went back up to my GitHub. I created a pull request, and I sent it back to the original author, who was then able to merge the changes that I made. And that is everything you need to know about Git in order to be dangerous with it. And so you'll notice if we go through this blog post that I kept open just to make sure I didn't skip any steps, this is definitely not a replacement for learning Git. This is just kind of a cheat sheet, kind of a crash course. I cloned. If I'd already cloned, I could pull. Git pull in a repository will just get the changes that exist upstream. I made a new branch, and I checked it out. This is making the changes. I use git status, git add, git commit, git push with the flags. And then I don't talk about pull requests here because it's supposed to be system agnostic. But like I said, if that goes quickly, or if that went too quickly, check out my cheat sheet or watch one of those Pluralsight courses. There's lots of material out there to help you. And do I still have this open?
So question.
Oh, I have
A question?
Yes, a question.
Yep. So the question is just about that. You can clone. Once you fork, then you can clone from there, and then
Question.
you could do all your work from master and just push back to master. And so long as you haven't deviated, the practice of branching is a purpose, or is a cleaning thing, or like keeping things organized, or what's the story with that, as opposed to just leaving branch master.
Yeah. So the benefits of branching aren't necessarily apparent when we make a really tiny, seemingly insignificant change like this. Um, the reason I wanted to show branching was because you're not always going to need to create a fork. Oftentimes, when you're doing this professionally, you'll be doing it on a repository that you have permissions to work with. In this case, my Thomas Rayner account had no permissions to the Write Code Pet Cats account. And so I wasn't able to just create a branch on that repository. I had to create a fork into my own repository. But when you're working at work, where you have permissions to manipulate the code and to work within that repository, then that's where you're going to want to create a branch to isolate your changes. In this particular scenario, yeah, I could have just used my own master branch and then made a pull request from that master branch to the other master branch in the Write Code Pet Cats repo. But I wanted to show you the branching concept because that's more normally how you're going to be working at work, so to speak. You're going to be working with repositories that you have permissions to edit master, or you have permissions to create branches, and you still want to go through the act of creating a pull request because you don't want to just edit master all willy-nilly. You want to do it in a separate branch. I
So
had another. Sorry,
pull
go ahead.
request from sorry. So do you pull requests from one branch to master?
Yeah. So what I could have done here is, do I have it still? That's the wrong one. Do I have
So
it
the same
here?
function, just that whole pull request, you just can move from your branch, yeah.
Yeah. So screw it. Let's just go to GitHub and let's go to where's my fork? So I've got two branches here, right? This is my fork, and actually, if you look at my master branch, these changes aren't there. These changes are in my fixit branch. So what I could do is, if this was a larger internal project, not just a fork of a public project, I could go create a pull request, create a new pull request, and then say, I want to go into my repository, master branch, and there isn't anything to compare. Example comparisons, come here. There we go. I want to go from into my master branch from my fixit branch. And because I've selected just my own repository, it's taken out some of that, some of those options. And it says I can compare across forks to get that back. But so here I'm going into my Thomas Rayner Catfax master from my Thomas Rayner Catfax fixit branch. And so this is more reflective of if you're working on code that you do have jurisdiction over, like if this is your work repository and you have permissions to do stuff to it, but you want to go through the change management process and you want to have people review your code before it makes it into master, because usually master is production ready code. It's not necessarily code that you're just willing to edit on the go. It's code that hey, we made a branch, made all our changes, tested it, and now I think it's ready for prime time, so I want to pull it into master. So I'm going to do that request. The rest of this all looks the same pretty much, except of where the destination is. So I create this pull request. I get all the same stuff that I had got before, and I create my pull request. And this all, again, looks the same, except for where I am. This is just saying, and I go in here and say files changed. Thomas Rayner wants to merge one commit into master from fixit. It's the same commit, it's the same change. I can go add a reviewer here. I could have given this a little bit more information, but you'll see I can merge this pull request, or maybe I'm not allowed to merge this pull request until it's been reviewed by 2 of my teammates, or it's passed some CI/CD integration or something like that. But then I can come ahead here and I have permissions to merge this because it's my fork. And then if I go back into code in master, oh, come here. I've got my change there. And that's a little bit more reflective of what you'll see professionally, where you have that repository and you just made a branch, made your changes, pushed your branch back up, and then you wanted to do a pull request to pull from your working branch into your master branch. Master you kind of treat as your gold production ready copy, and that avoids the need for forking if you can get away with doing that. But in this scenario, where this was a community module that I had no relationship with this person, I just saw their cool project and I wanted to contribute to it, I had to work around it this way. Does that answer your question?
That was a perfect answer. That was perfect.
Okay, perfect. Just looking through the chat. Is it good practice to delete the branch once you're done with it? There are varying schools of thought on that. So like now, I'm done with this fix-it branch, right? However, it depends a little bit on your workflow. That's a complicated answer, to be honest. On the one hand, you could say, oh yeah, I'm done. I made all my changes. Now I can delete this branch, and I won't have it cluttering stuff up. But maybe this is just a dev branch that I just have ongoing development work. This is a huge project, right? I'm going to make tons of changes to this in the future and add tons of features. So I want to have an ongoing development branch. I might want to leave that one there, or and do all my work in it. It kind of depends on what works well for you guys. Honestly, in my organization, we keep our branches around just so that people don't end up looking for them. It can get a little bit cluttered, but you can search, right? Like if this was a giant ass list, I could go and see where, oh, it started with fix it, and this filtered down to fix it. And if you kind of know what you're looking for, it gets helpful. We prefix all of our branches with the number of a user story. So we kind of know which feature you're working on. So if you want to find the code or the branch that's related to that story, you can. And so, yeah, you should probably do some changes. You should probably do some cleanup and make sure that you don't have a bunch of stuff just sitting here unnecessarily. But yeah, you don't necessarily have to. The GUI is super useful, agreed, especially when you're just getting started. I highly recommend working your way through the command line and just kind of forcing yourself to do it. I honestly do sincerely think that will end up giving you the best experience because it's universal and it's very well supported in the community. There's tons and tons of resources, and it is the standard. It is the original way that people intended you to work with Git. That being said, there's lots of different ways of interacting with Git, and they don't have to be like this. You can use the VS Code integration. You can use the GitHub Desktop. There's lots of different options for you. Adil has a question. Adil has a great question. He submitted a pull request to one of my repositories that I meant to merge on stream. This is a repository I have here. I can show you what it does. It's a Visual Studio Code extension, and it does, it inserts random words in Pascal case. Once it activates the extension, come on. Oh, did that not go? Oops. Oh, there it goes. It's entering words. And you might notice that they're all particularly cased. And if I go into my settings, I can change my default casing. I can change the word list that it pulls from. And Adil has gone ahead and added a Star Trek word list. He has an issue tag that he opened for it. You can see, Captain, we cannot leave this list ignored. And he's added this pull request, and he added it correctly. I've already reviewed this on my own time here. So I'm going to go back here, and I'll add a comment to it thanking him later. But I'll merge this pull request, and I'll go and bundle that up later. Thank you very much for your word list. The importance of the master branch becomes visible when you have automated testing and deployment. Very much. Yeah, a lot of people will tie their CI/CD systems to a particular branch, which is a good idea because you don't necessarily want the same build and release processes happening to every single branch you have. And so keeping master as your kind of gold standard production level code is a good idea. Working with a team really made branches and PR merges click. Yeah, absolutely. The collaboration aspect is great. I created this stupid little VS Code extension just for fun because I wanted to play around with TypeScript. And I created kind of a format where you could pretty conveniently add your own word lists. And so some people did. And they added the Star Trek one. I think the Star Wars one came from him too. Or maybe it was the Middle Earth one, or maybe it was both. I can't remember now. But that's fun. This is awesome. This is the community kind of playing around together and improving stuff for the collective good. Yeah, so yeah, follow-up talks about merging and rebasing. That's definitely beyond the scope of this. Really, all I wanted to get through was kind of just enough to be dangerous there. Updating your fork from the original, as many people are making changes. It's a pretty straightforward process. GitHub update fork, syncing a fork. And it'll tell you exactly what you need to do. It'll say, hey, before you can sync, you need to configure a remote that points to the upstream repository. And then once you do that, here's exactly what you do. And so this was more stuff. Like we've already been going an hour and 15 minutes-ish, so I don't want to make this go even longer. Like Git is an enormously deep rabbit hole that you can continue diving into, and you totally should. Like this is a critical piece of information to know, but we just don't have time to cover it right now. But you can see GitHub. There's lots of information available for stuff like that. Okay, so I don't see any more questions in the chat. Are there any more questions just among people who wish to unmute themselves?
Yep, feel free to unmute. And if nobody wants to chime in, certainly say thanks so much. You know, Thomas, thanks so much. And we'll see you all in 2 weeks.
Fantastic. Stevie, yes, you can have a sticker if I can have a coaster. All right, guys, thank you very much. Please do hit me up on Twitter if you get stuck on something like this, or you have questions about the blog post or something that we talked about, or if you're working through it and it's not clicking or whatever, and you just wanted to get my perspective. Find me, follow me on GitHub, or join the PowerShell Discord and Slack. That's honestly a great. You'll level up your PowerShell knowledge there for sure. And you can find my Pluralsight courses and books at their respective places of hosting. Otherwise, thank you guys so much for coming and listening to me ramble about Git for honestly longer than I expected. I hope you learned something. And otherwise, enjoy the rest of your evening, and hope you get to put this to work. It's not so scary. It's just Git.